listeners. I'm Isaac Adol, a student of CSA College of Science and Technology. I'm presenting on assessment of production and profitability of stocking sizes and densities of Nile tilapia for small-scale pond farming. And the outline of my presentations are as shown on the screen: background, introduction, problem statement, aim and objectives, materials and methods, results and discussion, and conclusion, as well as recommendation. Background: aquaculture is gaining importance in the world, contribution to total fish supply. Aquaculture alone contributes 46% of the total world fish production. And why is this so? Because there has been decline in capture fishes from the existing inland water bodies. And also 52% of the fish produced through aquaculture are consumed directly by humans, and this call for more work on aquaculture. Problem statement: it is unclear the type of farming system, stocking size and density small-scale tilapia pond farmers should use to maximize yield and profit in the production sector. In Ghana, stocking size of tilapia for grow-out ponds production has been dictated by the common size of fingers available from tilapia hatcheries, because majority, that is 85% of small-scale farmers, stock their ponds and cage with fries as low as 2 grams instead of the recommended fingering size of at least 15 grams as the standard for aquaculture production in Ghana. There is inadequate information on stocking size and density that small-scale tilapia pond farmers higher production level and profits. This work was carried out to evaluate the production and the profitability of different stocking size and density of Nile tilapia in the small-scale pond farming in Ghana. And the objectives are as follows: 1, to compare the growth, performance, and the survival of different stocking size and density of tilapia fingerlings within similar or same time frame, and also to determine the water quality characteristics at different stocking size and density, and lastly, to determine the cost effectiveness of all niloticus production at different stocking sizes and density. The research work took place at ADEC, as shown on the map, and the rare work took place as where we have the red dotted point, and that is a branch or a station that belongs to CSI Water Research Institute. That is where aquaculture demonstration is being ongoing on there, and the purpose there is to multiply seedlings, tilapia seeds for production. The actual work started with the clearing of the pond, and the pond was drained, the bottom was allowed to dry, and lime was also applied, and the ponds were filled from the water from the water leg to a brim or to its mark. Monosex male Nile tilapia of generation 11 was used for the stocking in the experimental ponds, and it was a 2-factorial experimental design with 4 treatments that was used. That is, after pairing them, it was 2 grams at 3 meters square as treatment A, and 2 grams at 6 meters square treatment B, and 10 grams at 3 meters square treatment C, and the lastly 10 grams at 6 meters square as treatment D. And all the treatments were replicated, that is A1, A2, B1, B2, C1, C2, and D1, D2. The fish were allowed to acclimatize for 5 days before the trial commenced, and mortality encountered during this study were all replaced. All stock fingerlings were grown for 154 days. So this is where we counted the fishes, and they were conditioned before it was stocked. And this is the stocking. This is the experimental design. That is, a stocking size of 2 grams and 10 grams was used, and they were paired with a stocking density of 3 fish per meter square and 6 fish per meter square. So in total, 7,200 fingerlings were stocked. and treatment 1, treatment A, took 600, whilst the treatment B also took 1200. C took 600 and D took 1200. So in all, 7200 fingerlings were sold. They were fed with Ranan feed, that is 40% crude protein, that is at the initial body weight per day of 8%, was given to treatment A and B, as shown from the table 1 earlier, while the C and D were fed with 6% body weight. Adjustment of the amount of feed was done every week, that is after sampling has been done, and the moment there's an increase in body weight, it affects the feed that is also given to the fingerlings. Growth and water monitoring. Biweekly sampling of fish were done every 2 weeks, and we take the fish length were taken, the fish were also taken, and the water quality was also taken. There for the temperature, it was taken on the spot from the field using the thermometer, whilst sample was taken to the lab to take the other water parameters. Equation for determining the growth parameters. I did the data for weight gain, specific growth weight, individual condition factor, feed conversion ratio, and the feed efficiency were used. So the formulas on the screen were used to do those various calculations. For economic profitability, the revenue was calculated from the sale of fish produced. All fish were sold at the market price to small size fish buyers or mongers. The net income, which is the difference between the total revenue and the total cost for the production results in net income or profit, was computed using the formula below. So this formula was used to compute the total the profitability of the production, and the return on variable cost was also determined using the formula on the screen. Statistical analysis. Our software version were used with the help of the models as shown on the screen. That is for the weight gain, specific growth rate, the feed conversion ratio, and the feed efficiency were determined using this model as shown on the screen. While the ascent transform upon the survival weight were also analyzed using this equation. This model was also used, and the p-value of in type 3 sum of square were calculated using the packet car phosphorus, that is to determine the significant differences between them. So the figures below 0.01 were deemed as significant for the study. So this is the fish growth pattern for the results. So the first pattern, this is how they all started well. They started well with the initial weight, that is the 2 gram at 3 meters square, and the 2 gram at 6 meters square, the 10 gram at 3 meters square, and the 10 gram at 6 meters square. If you look at them, you see that the 10 gram was above because there was a significant difference at the initial weight, that's the 10 and the 2, and they all took off. But interesting, at the point of the the 5th week of sampling, that is where I don't know, should I say, miracle started taking place, because the 2 gram at 3 meters square took over that one of the 10 gram at 6 meters square to follow the 10 gram at 6 meters square as seen from the graph, while the 10 gram at 6 meters square was also coming down, and it was also moving in line with the 2 gram at the 6 meters square. So in all, finally it was surely clear on the graph that the 10 gram at 3 meters square took the higher or the finer or the higher stocking, the higher finer weight as seen from the screen. And there was also a challenge that as a recruit, the fish started giving birth within the ponds, and it was clearly shown from the graph that the 2 gram at 6 meters recorded the highest recruit weight of 14.18 kilogram, while the 10 gram at 6 meters square was the least. Results and discussion continues. She said the water quality parameter was also studied, and in the table above, for the temperature, there was no significant differences between them, and they were all within the range. The temperature and the pH and the turbidity, they were all, and the alkalinity were all within the range required for tilapia production, with the exception of the ammonia nitrogen, which was a little bit higher. And then the DO was also a little bit low, but it was a little bit low. It was only the 10 gram at 6 meters square that recorded a little bit higher DO. That was good for the production. And for the economic analysis, looking at the net income obtained from the culture of the different stocking sizes, the 2 gram and the 10 gram. And for the net income, the 2 gram at 6 meters square recorded the highest. And that was the reason was that the thing was sold to the small fish, the fishmongers, those who sell the kinky and the other food product. And for them, they were in need of the 2 gram. And that is why it was sold also to them at that time. And it was clearly shown that the 2 gram, because they were having, though they didn't reach the higher size, but they were smallest and they were also large in number. When it was sold at the price as at when it was harvested, that is the 11 cedi, the 2 gram at 6 meters recorded the highest, with the 10 gram at 3 meters square also being the least. And in terms of the return on the variable cost, it was also shown clearly that the 2 gram at 6 meters recorded the highest, with the 10 gram at 6 meters being the least. But when sensitivity analysis was conducted and the price was adjusted, because usually when at the end of the production, when the target is being when the hotels and the other big enterprises being targeted as where since they need the larger sizes, and if you have to be sold to them, the price usually changes, because the larger size usually attracted higher price as compared to the smaller sizes. So when the price was adjusted, it was promised, it was showing a little level of promise that the 10 gram will be selling at a higher price, and as shown from the graph, it was the profit was 1,099.5, followed by the 2 gram at the 6 meters square, with the 10 gram at the 6 meters square being the least. And the same thing also followed by the return to the variable cost. The 10 gram also recorded the highest, with the 10 gram at 6 meters square being the least. So in all, when the initial weight or the stocking size of fish is high, it usually influences the body weight during the growth period, as shown from the graph. And the 3 fish per meter square perform significantly than the 6 meters square in weight gain. And this may be attributed to the high stocking density as an inhibitory factor for fish growth due to the competition for food and space. And the lower stocking density usually led to higher specific growth rate. Fish in all treatment make use of the feed given, but did not reflect much in their body weight gain, and this could be due to the spawning that took place in all the pond. The energy that they are supposed to use for their growth was rather used for spawning, which affected their final weight. Generally, the water temperature, the pH, and alkalinity were all within the optimal range required by the tilapia for growth. The average DO was below the optimal range required for tilapia growth, and this could be due to the season in which the fish were also caught, and as well as because of the stocking sizes. It also the stocking density also affected the level of DO oxygen present because they were all competing, and the recruits were also competing with the main one for oxygen. The ammonia nitrogen recorded were above the recommended rate stated because the stocking density was high plus the recruits, and they were all defecating or releasing waste, excreting waste product into the water, in addition to the feed, the excess feed that was also in the water, therefore leading to the building up of high nitrogen content within the ammonia nitrogen content within the pond. All the treatments were profitable with the 2 gram at fish meter square recording the highest return to variable cost, while the 10 gram was the least when it was the market price was used. And this was in line with the finding of Waterboard, who reported that there is a positive relationship between the stocking density and the production yield for Nile. All the fish were sold to small fish buyers at the same price of 11 cedi. At regular or formal market, the buyers discriminate harvest fish prices by sizes, and therefore lower size reached by the 2 gram at 6 meters and the 10 gram at 6 meters square would have been rejected, not purchased at all. Because if we were to be sent to the big hotels or the restaurant, they are not interested in the smaller sizes, they need the bigger sizes. That is why the sensitivity analysis test was analyzed, and it will show that the larger size reached by the 10 gram at 3 fish meter square, followed by the 2 gram at the 3 fish meter square, could generate net profit more than the current profit margin of the 2 gram at 6 fish per meter square at a price of Ghana 14 cedi and above. Therefore, I conclude by saying that the 10 gram fish at 10 gram at 3 fish meter square was the best in terms of production, with the 2 gram at the 6 meter square being the least. For economic benefit, 2 gram fish at meter gave the higher return to variable cost when sold in a specialized market, that is small size fish buys, but harvest size of 10 gram at 3 fish meter square will be better option in a regular formal tilapia market, where it attracts fish a higher price discrimination per kilogram of fish. Recommendation: fish farmers are to rear bigger size Nile tilapia fingerling, preferably size above 10 gram, and maintain the stocking density of 3 fish per meter square in order to realize higher yield, survival, and economic return, because they will help them to give, as the study show, a bigger size at the end, which will attract them more buyers at a good price. More work needs to be done on hormonal feed to achieve 100% monoset, because for tilapia, even when there's one male that find one female that find itself in the midst of the male, there will be disaster inside there. So more work need to be done, so that at least 100% need to be get, so that will help especially the pond farmers, so that they can also get their income at the end of the production. Thank you very much for your audience.